Okay, so let's talk about groundwater usage and how groundwater usage can be unsustainable or sustainable depending on how we use it. So groundwater, we have to get it from wells, and there are many different types of wells. This picture does a nice job of showing natural wells. So anytime a water enters an aquifer at a high elevation and travels down in terms of elevation, then it's going to exert pressure behind the natural well. So if you put a well into the ground here, for example, the water will come out as long as it's lower than the elevation at which the water went in. Here's another example of a water table well. So you can think of an old-fashioned well where people just dug into the ground and they put like a stone wall around the well, and you could fetch a pail of water out of the well. So that's an old-fashioned water table well. And then you can see this water is flowing down. It can enter all these wells, and you can get different sources for groundwater. And in this one, I should mention, the water is flowing to this well from this aquifer, and then this is a different aquifer. So you can have multiple layers of aquifers. Most groundwater in the United States, we pump it out of the ground using a pumping well. So most wells are not natural wells. We're too impatient, we need too much water, so we can't use those old-fashioned pumping wells with buckets. So we pump, we drill a hole into the ground, and then we put a pump on it, and then we pump that water out of the aquifer. And when we do that, it causes the water table, so the water table used to be here, it will cause that water table to decrease. So it's not at the same height as it used to be underground. And that decrease in height is right here is called drawdown. So you're drawing down the water table. Groundwater residence time, as you recall from past lectures, is about 10,000 years for long periods, for very deep aquifers. And of course, for more shallow aquifers, it's much shorter, but it can be up to 10,000 years. So when we're talking about groundwater, groundwater is a renewable resource if we pump it only at the rate at which the aquifer is being recharged. If we pump the water out faster than that aquifer is being recharged, then the water becomes a non-renewable resource. And so, when we talk about water, it's just like if you had a river. If you pumped the water out of the river at a rate faster than water is coming downstream, you're going to have a dry riverbed. That same thing happens when we pump water out of an aquifer, because it's basically an underground river where water is just flowing through rocks and soil sediments. So let's talk about a specific aquifer, and this is a very important aquifer for agriculture in the kind of Midwestern United States. This area is known as the High Plains or Ogallala Aquifer. 20% of all U.S. farmland is irrigated with water from the Ogallala Aquifer. It is found under the states of Texas, New Mexico, Oklahoma, Kansas, Colorado, Nebraska, Wyoming, and South Dakota. So it's this huge range up and down through the middle part of the country. And about 200,000 wells have been drilled into this aquifer since the 1940s. Right now we are pumping water out of that aquifer at a rate faster than it's being recharged. So the recharge rate is about 21 millimeters of water per year, and we're currently pumping at a rate of about 55 millimeters per year. And of course that does vary a little bit by the region of the aquifer, but that's the average. As a result of these high pumping rates, the water table in this aquifer has dropped more than 300 feet in some areas. And you can read more about this aquifer in the Mission 2012 Clean Water Report by some scientists at MIT, and in a report by the Texas Water Development Board. This is a nice map just showing the extent of this Ogallala or High Plains aquifer. So you can see it really does It really is situated under this huge area in the middle, southern and middle states of the United States. So what happens when we pump too much water out of the ground? It doesn't just affect the environment underground, it also affects our above ground environment. So when you pump water, because groundwater and surface water are connected, when you pump too much water out of the ground, you're going to be draining water from above as well, because any surface water that was connected to the aquifers, you'll be pulling that water through the aquifer out of your pump. So we see that this causes drainage of wetlands. And here's a picture of a wetland that used to have water in it and no longer does. You can see from the vegetation that it was a wetland. We also see land subsidence. So when you drain the water out of an aquifer is just porous materials. The water used to help support the weight of the land above it. And when you pull that water out, then that land is going to sink because of the weight of the soil and rocks above it. And so it's going to compress the soils and rocks below, and you're going to have land that sinks. So when that happens, you can have the land either just sinks uniformly, or you can have sinkholes develop where there's like the land caves in, and you can get a hole developing in the surface of the earth as that land compresses and falls in. This happens a lot, like with houses that are sitting on the land. It compresses, the house falls in a little bit. Often it's not as dramatic as this, where we have a big hole in the ground. Generally, you just see a crack in the foundation. Sewer pipes can fracture, and the house itself can be tippy, so it's not flat anymore. Another thing that we see when we pump too much groundwater out is that salt water, so just like we have surface water in rivers and lakes connected to our groundwater systems, we have ocean systems connected to groundwater if you're in a coastal region. And so as you pump more water, you're going to draw in salt water from the ocean region, and it's going to infiltrate soils and aquifers, and then it makes that water in the aquifer salty, and it makes the soil salty. And so you can't drink the water, and it's also not really good for farming if that water gets too salty, if the soils get salty too. So I like this graphic just because it kind of summarizes some of the impacts we saw if you pump too much water out. So you can see here's a well that's pumping water out. This is a very deep well. Your neighbors might not like you because their wells are going to go dry because you're lowering the water table below the level of their well. Also, it can cause subsidence, so your house can lower, and it won't lower necessarily evenly, so you have a tilting house. Water from any coastal areas, the salt water can intrude and come into your aquifer, and it will go up into the well, and it will also cause the aquifer in general to become salty. The only thing this graphic doesn't show is the impact on wetlands, where water is being pulled out of the wetlands. So instead we'll look at that here. Here's a picture of the Santa Cruz River near Tucson, Arizona. In Tucson and Phoenix, we've been pumping water out of aquifers for a long time, and as a result, the water table has dropped between 300 to 500 feet in some areas. So as we do that, we're draining rivers, natural river areas, what we call riparian areas. So the Santa Cruz River in 1942, you'll see lots of, it's hard to tell, it's black and white. There's lots of trees growing along the Santa Cruz River, which flows right through here. That's because they're supported by the water that's in the river. This is a nice area. There's beavers even along this river. But by 1989, so much water had been pumped out of the surrounding aquifer that this riverbed was mostly dry, and the trees were dying off. This is a famous picture on the left part of the slide of a gentleman standing next to a picture of where the land used to be and where the land is in 1977. So in 1925, this was the level of the land in the San Joaquin Valley in California. But as more and more groundwater was pumped out of the ground, the land kept subsiding or sinking down. And so you can see from 1925 to 1977 how much subsidence took place in that area. And he's there for scale, so you can kind of see probably 6 people tall is the difference. And then here's a picture in Pima County, Arizona, where we see a subsidence area. As a result, the road surface is not uneven, and there's sinkholes in the road. So they're warning people, hey, be careful, the road has sunk as a result of subsidence. There are many resources for this series of lectures, so if you'd like to check any of them out, please download the lecture file, and you can click on these links and visit them for yourself.